Good evening, everybody. Welcome to episode 46 of Games with Go. This is going to be the final episode. I might stream some occasionally after this, but it'll be the end of the regular 3-day-a-week stream. And today we're going to work on some more lighting. We're going to add specular highlights to our shader, which are the kind of on shiny objects, kind of the bright spots you see reflecting from a light source. We're going to add that, and then we're going to fix up our camera a little bit. Our first-person shooter controls kind of have some problems right now, and they're a little tricky to fix if you're not familiar with SDL2. So we'll go through that too. And then, if you've been following along all this time, you'll be well poised to continue learning this stuff. LearnOpenGL.com is a great place to keep going. A lot of the stuff we've been doing is very similar to their tutorials. We've added some things and done them in Go instead of C++. But at this point, you should have no trouble continuing on and following along with these if you want to learn more about 3D graphics. All right, so let's get going. First up, let's fix the camera controls. So I'll show you the problem. You may have already noticed if you've been playing along with it at home. So if you move left and right, there's a limit to how far you can go. Right? Like you go left and it stops, you go right and it stops. And the reason for that is once our mouse is hitting the edge of the window, we don't get any new X coordinates from it. It just hits the maximum, like this is at 0 now. And if you keep moving left, you still just get 0 for X. Right? We've captured the mouse, so we're not seeing the cursor and we can't leave the window, but we can't get X's less than 0 or greater than the width of the window. So it doesn't move anymore. So to solve that, we need to capture mouse events rather than asking where is the mouse each frame, right? So currently we are doing, where are we getting the mouse? Right here, we're getting the mouse state each frame of our game loop. We're saying where is X and where is Y. So instead of that, we need to use the event system here. And we want to capture not just quit events, but mouse motion events. And then we're going to actually need that event. So up here, this is called a type switch, where we are getting what, like this is an interface, and we're seeing which one it is, which actual type it is. We actually want to do stuff with it. So we're going to say, this is the syntax for it. Maybe it's like that. Yeah. So now this will be, in here, it'll be a quit event, and in here, it'll be a mouse motion event. So we can use it and get the relative motion of X and Y. So instead of getting an absolute coordinate, you'll see how much it moved since the last mouse motion event. Right, so we're not going to need previous mouse X and previous mouse Y anymore. This interface is actually a little bit better. Because we're getting relative motion, we don't have to calculate the relative motion ourselves anymore. So we get rid of previous mouse, get rid of mouse X, mouse Y there. No longer have to set previous mouse afterwards. So instead we're just going to have mouse X, mouse Y, what are these? And 32s. Okay, so then here you can say mouse X equals XREL, mouse Y equals YREL. Capital Y. And then when we update the camera, we no longer have to subtract from previous mouse X because these are already relative amounts. So we can just send them like this. And let's give it a try. Okay, so if you're following along at home, you will see that this is not working. I'll have to step out on purpose to illustrate what's going on. Like you kind of move your mouse and it lags. It's a very bizarre feeling. It'd be a good mechanic for like if you're drunk in the game. So what is wrong? What's wrong is between frames, you might have multiple mouse events. So we are only giving the relative motion of the last mouse event that we happen to find each frame, right? This is a loop. There might be 100 mouse events each frame. Mouse events come in very fast. So what you actually need to do each frame is set mouse X and mouse Y equal to 0, and then keep adding to them. Add all of the relative mouse motion events each frame. And now it works properly. You can turn all the way around and then fly through the scene a lot better than before. All right, that is it for the camera fix. So next up, let's start adding specular highlights. So specular highlights, the way they look, they depend on like where the highlight goes on the object. It depends on your point of view, the viewer's point of view. So in order to draw them properly, we need to know where the camera is, right? Where the user is looking at the object from. And we don't currently have that in our shader anywhere, right? We have the position of the light, but not the position of the camera or the viewer. So we're gonna need to add that. Let's go ahead and add a uniform for it. So that's gonna be a position just like light position, but it's gonna be view position. And then let's organize things here a little bit. So I'm gonna move the ambient calculation up here. And then we'll have diffuse, then we'll have specular. Okay, so we've got our view position, and now we need to calculate how to do a specular highlight. So we're going to get a vector from the pixel we're going to render to the viewer. And you can do that with subtraction of vectors. Then we need a reflection direction. And there's actually a reflect keyword built into GLSL. So we take the reverse of the light direction and we give it the normal of the fragment, so that it knows how to bounce it, how to reflect it. All right, so now we're going to get sort of the magnitude of the highlight. Using the dot product of the view and reflection directors. And again, this is just to make it never be negative. Right, if it's negative 0, it will be bigger, so it'll be 0. And then we'll play around with some of these values to see how it changes things. Let's call this 0.5 for now. Okay, so now we're going to do ambient plus diffuse plus specular. Add them all together. So let's see how that goes, but first we need to add the view position as a uniform. So let's give it a try. Shader program. Setback 3. And we can get that from our camera. Camera has its position all set. That should be all it needs. Shader error. Oh. Unlike Go, you need semicolons. I'm not seeing much. Let's play around with it. So let's Alt Tab, shrink it down. Move it over there. All right, let's play with our shader, see if we can figure out what's wrong. I can make this bigger. That didn't do anything. Let's see. One of the things that can be challenging about shaders is you can't like easily just like printf a value to see what it is or debug it. There are some tools that can let you do things like that. And someone does actually have a clever printf implementation, like a function you can put in your shaders, which is kind of cool. All right, view dir should be view position minus fragment position normalized. Reflect dir. Power of max. Let's make the light all white, just so it's a little bit nicer to look at. Seems like specular is just 0. Or nearly so. Wonder if the light is too far away. Let's play with how far away the light is. Let's see. Our cubes. Let's get one real close. So one of them's at 0, 0, 0. So let's put one light at 0, 0, 1. Okay, yeah. Now you can kind of see it. You can see the highlight right in the middle. Move it over here. Now we can play with our shader. So yeah, you can see we can make it weaker, stronger. All right. You can see how it moves as we move. Let me slow down the movement speed a little bit. Let's see, where are we setting that? New camera speed. So yeah, you can see how the highlight moves left and right as we do. All right, that is specular highlights. And now you can go on from here and do things like handling directional lights, spotlights, multiple lights. You know, we just have the 1, but there's no reason you can't have 6 or 10. It just starts to get slower and slower the more you add. All right, any questions about the specular highlighting or the camera code or any past episodes or programming in general? So if you go along with learning more OpenGL with Learn OpenGL, you get to do some cool stuff. There's a model loading. They've got a cool, you get to load this guy. It was from Crisis, I think, the first Crisis game. And there's also a nice asteroid lesson. So in this one, you're rendering like thousands and thousands of asteroids, but they're all the same asteroid, and there's a way to, with OpenGL, to save on performance a lot. Like if you try to render each asteroid as its own model, it's too much and the frame rate gets really low. But with instancing, you can just use the same model in multiple places, and it goes really fast. So that's a fun one that you can like, you could start with this and then make an asteroids game out of it. So yeah, if you want to learn more OpenGL, follow along with this. At this point, you'll know how to translate the stuff in here into Go. And you can add to our GoGL library to make it a nicer interface if you want to. All right, everyone, that's going to be it. So I'll hang on for 5 more minutes in case there's any questions or comments. All right, everyone, good night. And if you keep programming, feel free to hit me up on Twitter if you have questions or run into problems. I will see you guys later. Bye.